I work for a firm out of New York, Acronym. We do search marketing, sort of manage our client search marketing campaigns. And we're building some really cool dashboarding applications right now. Actually, currently looking for a back-end developer, PHP, preferably somebody who knows Symfony, and a front-end developer, somebody just with awesome JavaScript chops. So I have job descriptions available upon request. You know, if you're interested, just let me know. Tonight I'll be talking about scalable front-end architecture, specifically an approach with jQuery and jQuery-UI. My name, for those of you who don't know me, Ryan Bales. You can find me on Twitter. I'm currently the UI project manager for this company in New York, Acronym. The majority of our business is centered around managing our clients' search marketing campaigns, but about a year and a half ago we started building some dashboarding solutions for our in-house for our account managers and also for our clients' use. And this is just sort of a snapshot of one of our views. You can see, if you're not right behind me, there are a lot of widgets on this page, a lot of moving parts. Any one of the widgets are fully customizable, and it's all taking place in an asynchronous environment. So we have to communicate the user's intent to the back end asynchronously. The back end responds with new data, and we have to refresh the widgets. But this level of complexity, we really had to design the architecture with some serious thought. And we think that we've come up with an architecture that scales pretty well. But first I want to talk about scalability as it relates to front end. A lot of times we're talking about scale, we're talking about the back end, we're talking about limited hardware resources in a high demand environment. The front end is also a high demand environment. And it really has more to do with maintainability. Given more components being added to the architecture, the components become more complex. There are specific constraints that are added. Widgets have to work one way in one view, another way in another. And so we have to think about how we can organize our code so that it's maintainable given all of this complexity. So what does it look like? Just in terms of characteristics, it's modular, right? It's reusable, and certainly modularity goes a long way towards serving reusability. It's extensible, so we want to be able to extend existing functionality and create something new, add and override behaviors. And this is true for the aspects as well as the components. So when I say aspects, I really just mean the layers of the architecture. So persistence, presentation, all of this should be sort of abstracted from code that doesn't need to concern itself with these aspects. And then the components, full features, widgets that need to interact with other widgets and sort of include all layers of the architecture for a given feature. It bolsters convenience through convention, so standardization. We need to make sure that when we're maintaining code, when we're prototyping, we know, our developers know exactly where to go to add functionality, to fix broken crap. And so it's important that we have conventions throughout our architecture so that our developers can rely on that. And it's especially important when you're onboarding developers as well. It promotes sane organization of all of the components, so objects, persistence, presentational elements, messaging, and these are just some of the characteristics of what I would consider to be scalable and maintainable front-end architecture. Right, but jQuery, right? Seriously? And of course the look of disapproval. jQuery has a pretty bad reputation, I think. It's a fantastic library that people abuse to no end. And I'll talk about that a little more in just a minute. But why shouldn't anyone use Backbone or Knockout or any of the other frameworks that are available that sort of guide your hand toward maintainable, scalable front-end architecture? Well, obviously you should if you can. But a lot of times you're working in an environment where new tools aren't exactly invited into the environment, either because your boss thinks that it will hinder performance. They're unwilling to invest the time in learning the tool themselves, or they're afraid that they're not going to find talent that's able to, that knows their way around Backbone or Knockout or whatever library you're using. And then jQuery is everywhere, and of course that's an exaggeration, but it's ubiquitous. If you're not allowed to use Backbone, Knockout, or a number of other libraries, you're probably using jQuery and you're just dumping a lot of jQuery into one file. And of course, thinking about designing solutions with limited resources is always a good exercise. So if you're given just jQuery and jQuery-UI, what will you make of it? Sort of a survivalist guide to front-end architecture. So a common approach, and this is the abuse that I mentioned before. And I know everyone here, though they may not admit it, secretly has a project that they've long forgotten, where they had one JS file with one document-ready event handler, and all of their code was in this one file. I wish I could forget it. Yeah, exactly. I wish I could too, and it wasn't all that long ago. And of course, the file includes all of the aspects of all of the functionality for all of the views, creation and manipulation of DOM elements, inline event handlers, a ton of redundant code. And so we want to move away from this. So the format of this talk is basically a step-by-step look. So looking at step-by-step, how do we get to a more modular design for our front-end architecture? Starting with this common approach and ending with an architecture that's something like what we're using at Acronym. I've created this project, Frisk, and it's basically a project management tool. Let me just see if I can. Yeah, so it was basically the idea behind this was you could create tasks, you would create and manage states, and as these tasks are created, you can drop them into the different states and look at just at a very high level where these tasks were in the development process. You can check it out, fork it, sort of analyze the architecture that I describe as it relates to this project. I've got it on GitHub, and if I've got a little time, I'll look at the code more specifically, but in case you wanted something to play around with at home, you're welcome to play around with this. All right, so let's start with component modularity. Right now we have all of the functionality for all of our views in a single JS file. It's being executed on all of our views, so we're spending a lot of resources executing code that's just completely irrelevant on any given view. And maintaining code for a single view, of course, means poring over this huge file, looking at a ton of irrelevant code and trying to navigate it, which is difficult. So let's start by moving the view-specific functionality to view files. So we create a home, public JavaScript's views. I only use public JavaScript just because this is an application running on Express, and that's the convention. Each view will be represented by a single JS file. So on the index view, we'll have an index.js. And so simple task, but what have we accomplished? Now the browser is only executing the code that's specific to any given view, and making changes to any view is obviously a lot easier. You don't have to navigate all of the code in a single file. Next we have widgets, and this is really the crux of our architecture. So a lot of our components are commonly used among the views. So you notice if you just copy and paste code from that single JS file to all of your views, you're copying a lot of code into a number of different views. And so we want to abstract that. We want that to exist in one place, so that when we want to make changes to components, we can just make it in one place. And so let's look at requirements for our components. or this representation of our features. We want to be able to support options. So we may want a table widget to act one way on one view and another on another. We need to encapsulate data. So we're managing state. Each widget is managing its own state. We need to provide a public interface. We need to hide private implementation, and it needs to be extensible. So whenever we have a table widget and we want to create an advanced table widget with 3 or 4 new bells and whistles, it's easy enough to do. So we've decided to use jQuery-UI's Widget Factory. We've actually modified this a bit, but this is perfect for the sake of this talk. It uses so jQuery-UI's widgets themselves, the widgets that we're all familiar with, use their own method to define new widgets. So obviously we can use this same method to create our own widgets. It's a method of the jQuery prototype. I've linked the link to the wiki that sort of describes the use of the Widget Factory. And it works a lot like jQuery plugins. So it's just a method of the jQuery prototype. You need a jQuery wrapped element, call the widget class on it, and pass in options. And this is just a very basic example of creating a widget. It is the widget method of the jQuery prototype. The first argument is just the name of the widget. So this is a namespace and the name of the actual widget. If you don't provide a namespace, it'll just register it under a default namespace. The second optional argument is the superclass widget. So if you wanted to extend one of your existing widgets, you could of course do that. We try to only have one widget in any project that doesn't have a superclass. So we're all so if we need to add functionality to all of the widgets in one fell swoop, we can do that with like a core widget. And then the third argument is just the prototype. So this is just your implementation. And the way, of course, that you use this, you would wrap your element, call the widget class on it, and pass in any options.
Ryan, what goes in line 5 there? Is that JavaScript code that goes in line 5?
Line 5. Yes, yes. So this is your prototype. So any implementation, this is where the implementation goes.
So I'm confused. Is line 3 supposed to have the keyword function before that left curly brace? At the end there. Is that supposed to be an anonymous function you're passing in?
This is an object. It becomes the prototype for the widget.
So you have member function.
So you have three parameters. You have the name, you have the base class, and then you have a prototype, which defines the implementation for this particular widget. Okay. Hopefully, it'll become a little clearer. Quickly, the public interface. So one of the conventions of jQuery-UI is that within your implementation, so this is a little more fleshed out, methods and properties prefixed by the underscore are private, so you can't access them from any consuming code, and then anything that isn't is a public function. So here I am calling something public, and here I am calling something private. And an interesting note about calling inaccessible properties and functions is it just returns the object, the widget object. So jQuery-UI's widget options. So there are default options that are defined in the widget prototype. It's typically right at the head of the prototype, and they're just default values. The options are the first and only argument to the widget method, so that is the only thing that you would pass in when actually instantiating the widget. And the options are created, it's a deep copy of the prototype's options, and then they're merged with the options argument. So anything that you've provided as an argument to the widget class, or to the widget method, overrides any of the default values. And it also offers a mutator and accessor, sort of. There is an interface wherein you can just call the widget class, or call the widget method on the jQuery wrapped element, pass in option. If you only gave a second argument, it would actually return that option. And then if you provide a third argument, it actually sets that option to that value. So instantiation. The widget method is invoked on a jQuery wrapped element, of course. Like I said, the prototype options are copied and merged with the parameters. And then create is called, and then init is called. So these are two methods that are typically implemented in any widget class or any widget prototype that you implement. And it's interesting, you have to think sort of, you have to approach this sort of thoughtfully in that if you're calling the base classes create and init from within create and init, and that's a common pattern, then you need to make sure that if the base class actually needs to access any of the encapsulated data, that you're actually encapsulating all of the data in create. And so when the base class executes its init, all of the encapsulated data is there. So thinking about widgets and their application. So just some small notes about widgets. They're tightly bound to the DOM elements, obviously, because it's a function of jQuery. But features are often tightly bound to elements, which is convenient for us. Widgets often encapsulate other widgets, and in fact, in our architecture, even the view controller itself is a widget. So you'll see this in just a second. And this is exactly what I mean. So in our view, we actually create a widget, and we wrap the document and call that widget class on it. So in our architecture, on any given view, no matter how much JavaScript we're loading into the browser, there's only one document-ready event handler. And all it does is wrap the document and call the view widget on it. So there's only a single point of entry to the document ready. So it makes it a little easier to track down bugs. You know exactly where everything begins. And so we're going to create a home for our non-view widgets. It's in public JavaScript's widgets. We widgetize, obviously, our views, and we move all our component functionality to the widgets. So all of that code that's currently in our views that expresses some or represents some feature of the UI, we're going to make that a widget, and we're going to move it to the widgets directory. So what have we accomplished? Each widget now manages its own behavior, its own state, and there's greater modularity and reuse throughout the application. Awesome. Events. So we make use of the DOM's event system. We often we're listening independent consumers, and often most of our event handlers are actually registered at the view level. If it's something that's actually specific to the widget, then we'll keep it there. Like if it's managing any behavior of the elements within the widget's element. But if it's anything that relates to any other widgets, if there's any interaction, we bubble it all the way up to the document, and at the event level, or at the view level, that view widget actually registers the handler and does whatever it needs to.
Why do you do that? Bubble everything up to the top level? I assume there's some benefit that makes up for the...
It's mostly because it's mostly because that's the highest level of our architecture, and so So typically what we want to do is we want to do one of two things. We either want to pass a message to another widget, or we want to make some persistence call. And the persistence information we definitely don't want to put in the widget because it wouldn't be reusable on a different view. We don't encapsulate other widgets that aren't always available. So let me see. So let's say you have a chart. You have a grid, and you need to communicate some information between the two of them. Neither of them is going to encapsulate the other. So it makes sense to just bubble it up to the view, and the view, of course, encapsulates the point of content. Yeah, exactly.
Would you say it becomes the common bus?
It does, yeah, exactly. That's a good word for it.
Right.
Yes.
How do you suggest to manage dependencies between widgets? Let's say you have widget A that loads a list of categories and also that's the first one that is supposed to render the content of that category in the widget number in the widget B. So obviously you don't want to fire the event and having the widget not ready to receive data.
Yeah, that's a problem, and I actually list that as the last slide. There are a number of problems with the architecture, and that's one of them. And not only widget to widget also, so any modules that you define, just like libraries that you develop internally, it often makes sense for you to define requirements for a widget. This widget depends on some other number of libraries, and that just actually doesn't exist yet. So modules, we take a hint from the module pattern. Right now, we have just sort of ad hoc interfaces for our internal libraries, and that creates ambiguity. So if you have 3 developers on a team, 3 developers are going to develop the interface for a library 3 different ways, obviously. Libraries that inadvertently pollute the global namespace are dangerous. Yeah, so that's also true. So we want to also make sure that we're keeping the global namespace clean. We want to register everything in its appropriate namespace. So let's provide a system responsible for maintaining a consistent interface for accessing all of our libraries. So this is something that we've just developed. It's sort of a registrar for our modules. So this is just, it's a library that maintains information about your internal library, your other internal libraries. The libraries can just register themselves with a public interface and obscure whatever details they want to. It's not important that necessarily that you see the code here, but it is actually in the first project also, so you can look at it there. So yeah, this takes its inspiration from the module pattern. It protects the private implementation, and it exposes just what's necessary for the consumers. So you'll see I've just got here in a immediately invoked function expression. We define an object that has a return meh function, and we just register it as frisk util. So we're just registering this module, and it is this object. And then, of course, the usage down here, we call get module, get our actual module, and call it method. So step 3, moving towards modules. So we need to wrap all of our existing internal libraries in a module that makes itself known to the Module Registrar. So that's not difficult, but it takes some work in just exposing itself to, just registering itself to the registrar. And then we move all of our new modules to the module home, public JavaScript modules. And so now what have we accomplished? Well, internal libraries, with the exception of the jQuery plugins, are now found in the modules directory. And I'll give you a better look at the actual final application structure a little later on, but I didn't want to give that away now. And of course, we've established a consistent interface for accessing our internal library. So we know when we're looking for an internal library, we know exactly how to access it, and we know how it works. So let's start modularizing our aspects, the first being persistence. The problem now is even though we've got Vue widgets, we still have that code that makes the calls to jQuery Ajax. We might want to replace that at some point, and we might want to build in features like fixtures. And the persistence logic just doesn't belong in the widget. So our solution is to make use of events to communicate the intent, sort of what we were talking about a little earlier, translate that intent at the highest level, and then just separate the persistence logic. So we have another sort of, it's a plugin, the Service Registrar, and it works a lot like the Module Registrar. You add a service, you get a service, and the services look like this. So here we are just adding a service. We give it a name. We have several methods. So when we call getService, we call getService_frisk. It returns this object. And then we can call any of the methods that we need to. And really, we're just abstracting this logic from the consuming code. So we have the actual code to execute. We have, as a second argument, the method to call to return fixtures. And then as the third argument, whether to return fixtures or not. It's a boolean. And then we can actually implement our fixtures below. So if the backend's a little slow in implementing the interface, then we can just develop toward to the fixtures. And when the backend's done, as long as everyone's agreed on the right interface, it works seamlessly. And then consuming services. So this is just consuming the service frisk. We get states since we're dealing with states. We pass in an empty object as the data. This is our success handler, and this is our error handler. In a lot of cases, it makes sense to not have these as inline handlers, especially if the logic is particularly complex, but just for the sake of showing this, I just put it in line. As a step forward, we move to the services. We add the service locator to our plugins. We create a home for all of our services, so we know exactly where to go when we need to update the services, change the logic within, or add or remove fixtures. And we've moved all of the persistence logic out of the widgets. So what have we accomplished? We've abstracted the persistence. As the next aspect, presentation. So imperative programmatic presentation clutters our UI logic. You've probably seen a lot of code like this. I've written a lot of code like this, where we're creating elements on the fly, we're adding elements, we're adding attributes, properties, and then we end up adding it to the DOM. Of course, teams of dedicated web designers would not like this sort of use. So we need something declarative, something that's familiar for web designers, and it's something that's just easier to maintain, because this is ugly. So let's use templates, and since I promised jQuery, promised only jQuery, let's just use jQuery's template plugin. I know it's additional, to jQuery and jQuery-UI, but this is what we're going to use. So our presentation code becomes this. So we've got in our template, typically in the HTML, we've just got a script element of type JavaScript template. We use the jQuery templating syntax. We typically, within the widget, actually encapsulate these templates within the templates property. And we call jQuery template. It compiles the template, and when we actually need to use it, we go ahead and use it just below, and probably like a service success handler or something. So this is the final application structure. So we reserve vendor for third-party libraries, jQuery, jQuery-UI, the jQuery template plugin. Plugins we typically reserve for our own internal jQuery plugins. So anything that actually extends or adds anything to the jQuery prototype. Our modules are all of our internal libraries, registering themselves obviously in the Module Registrar. Our services contain all of our persistence logic and our fixtures. And our views are complete views, which are also widgets. And the widgets are the common widgets that are shared across the application.
Quick question.
Yeah.
So you have modules and widgets. I assume widgets are specific to display the front end stuff. And like, what's an example then of a module that you have?
Yeah.
What purpose do those serve really?
Yeah. So something like. So something like this, and this is not implemented. I began to implement this as one of the. It would be nice to have this in this architecture. So this is an observable library, or an event library, basically an event emitter. So one of the things that this architecture is obviously lacking is observable state. So what we're doing here is we're creating an observable class. And then we're actually exposing this as observable, so event observable. If we wanted to, as we grab state from the services, like in one of the success handlers, if we wanted to add the observable properties to that state, we could call get module, and we would say get the event module and extend this data with the observable.
It's kind of like infrastructural stuff, utility.
Yeah, helpers, classes, yeah.
Thanks.
Yeah.
Where would you put validation in this? Like if you had some large set of validation logic or complex validation, is that going to be one of the things you're going to pull off into?
Yeah, so our application is unique in that it's mostly read. It's a dashboarding solution. So most of our stuff is read. Validation is another approach that we're sort of trying to develop right now.
I mean, there's jQuery plugins for validation, so I wasn't sure if you just would drop in one of those, or if you would.
We're actually not even dealing with client-side validation at all.
Okay.
So it's mostly an interface that we've agreed upon with the back end. They typically just return validation error codes, and then we're able to translate those on the front end.
Another question.
Yeah.
I have a big question about what are fixtures?
Yeah. So fixtures are just they're fake data. If you needed something to test against before the services are available, it's just something that you can rely upon.
Okay.
So yeah, lots of stuff that probably could be improved. I'm sure others, a lot of you could come up with ideas as well. Obviously, the observable state. So it kind of sucks having to make these service calls, and then within the handlers, actually sort of funnel this this data into the widgets that actually need it. So it'd be nice to have some observable state that's passed down to the widgets, that's encapsulated within the widgets, and then when we get or on our service handlers, we can just update that state, and the widgets just respond because they've registered event handlers for update or whatever the event is. It's verbose. So it probably adds a lot of complexity. Certainly not as much complexity as the complexity that is sort of abstracted, but it's verbose. The type binding to the DOM. So for instance, you can't, within a widget, delete the widgets or remove the widgets element and then emit an event because that element's gone, right? So the DOM messaging, the DOM event doesn't actually work anymore. Widgets aren't homogeneous. So if you remember the public interface, you actually have to call the widget method on the element and then pass in as options the actual the actual method names. So you actually need to know what it is before you're calling any methods on it. So you can't just duck type it or anything. And of course, better management of dependencies. So, anything anyone else can think of?
Any questions?
Do you have, well, I guess I'm a little unclear. You were kind of showing the side project architecture, but you're saying it inspired by the architecture that your company has for the dashboard.
Right, exactly.
So I'm curious if, I'm assuming the little side project doesn't have this issue, but the dashboard, what kind of like performance, do you run into performance issues? So you're bubbling so many events up, or you have so many widgets, or is it like the browsers are fast enough?
Not typically. We don't have performance issues. So no.
Cool.
Yeah, certainly not as many performance issues as the back end. No, but there are no perceivable performance issues yet. So we haven't really even begun to think about it.
That brings to mind another question. Are you fortunate enough to like not have to support IE6, for example?
Oh yeah.
So maybe that helps.
That was a hard-fought battle, but
better, more modern browsers probably helps you that too.
yeah, IE8 plus.
Awesome.
Yeah. So yeah.
Right, do you have in place, or do you guys in the company have in place any kind of automatic testing? Because like a unit testing, I'm asking because one of the biggest challenges to actually test of the UI, because there are so many dependencies. You're sometimes expecting data, and sometimes you need synchronous data that has to come. Do you have any kind of advice?
Not unit testing, but we are using integration testing. We actually we're using actually node.js to manage our integration testing, and we're using the web driver. Yeah. So yeah, and it's wd.js, which is an awesome library. It's been great for us, but we're not doing any unit testing. We're using Node.js and WebDriver. So basically just it spawns a browser, performs a bunch of tests, and makes sure that your UI is functioning.
Is it similar to Phantom.js?
I'm not familiar with Phantom.js.
Browser without browser, but you can scrape everything and you get.
Yeah. Dylan, did you have a question?
Could you just like flip through the JavaScript files and just give us a quick tour of that?
Yeah, totally. So let's look at the view. Okay, so this is the view widget. You can see right away. It's a bit verbose. Here are our options with the default values. We never pass in any options to the view widgets. You can see at the bottom. Whoops. There's our single point of entry. We're wrapping the document. We call index view on it. Then we have our create and our init. We reserve the create typically for encapsulation. So initializing all of the internal state. Typically elements that we plan to turn into widgets later. Here's one of our templates. And then within the init, we call again to the base class. This syntax is a little different if you're using jQuery-UI or if you're using 1.9 or above. You can just call this super. And then we're calling one of our private methods to install the state container, which is one of our widgets. We basically just call the state container widget on the state container element. And then we register all our event handlers. And then we have our code basically organized by event handlers. Private methods, any public methods, and I'm And then within so here's our state container. This is the actual widget that contains all of the states, and then there's an additional widget that just represents the states themselves. I don't remember if you remember the UI all that well. We have our default options, create, reserved typically for encapsulation, adding any additional functionality to our element. Oh, and I don't even think I mentioned, this element is actually the jQuery wrapped element upon which this widget method was called. Register any event handlers. And the nice thing is about the way that we encapsulate widgets within widgets and use the DOM as a message bus is that we don't actually have to, so we have a state container, we have states within it. We don't have to set an event listener at the state container level and then emit something for the view to catch it. We just set the event handler on the state container and it bubbles all the way to the top. Any other specific things you guys wanted to see?
Yeah. So would you say that the primary reason why you create jQuery widgets for your views is that you want them to deal with events in the same way that widgets do? Or is it because views get reused in multiple places within the application?
Well, the reason we use widgets, because it's an object-oriented approach to organizing our components. And then it's tightly bound to a DOM element, which is typically, the feature typically revolves around an element. So we think that our UI and our features, it really aligns well with the widget architecture.
Is it a similar reason why you create some non-UI widgets? Because you want to tie into event handling for those?
Oh, we don't create any non-UI widgets. Yeah, I mean, if it's just an object that we need, then we just create objects and register them as modules.
Okay.
But yeah, I mean, if you're talking about UI features, it's always a widget. Yeah.
And what do you mean by a scalable jQuery-UI? The whole thing about?
Yeah. So I mean, scalable is probably a questionable term, but really, yeah, I mean, it's maintainable at a large scale. So as components are added to the application, as they become more complex, it remains maintainable. There are conventions that standardize the architecture.
Have you documented these conventions somewhere? Is it,
well, there is, of course, the documentation of the conventions of jQuery-UI.
Sure.
So I linked that, and the wiki page explains it pretty well.
Okay.
We've done some additional stuff that I haven't shown here that isn't documented, so I didn't even bother going into it. Anything else?
Can I ask you?
Yeah.
When you showed your dashboard, I was kind of thinking of like a model controller kind of a situation where maybe the user was going to change something. And I wanted to clarify, so do I understand, like in your dashboard, would the user perform some event that would lead to, you were saying, the event kind of bubbling up to the top, and that in effect would lead to like your service kind of thing that would hit the server and get the data back?
Yep.
But ultimately then that leads to an event that the widgets then kind of react to update the DOM. So it is kind of model view controller, or not really, or
sort of, but
yeah.
There's no real model.
Kind of
There's no real model. There's just state. There's just responses from the services, and those are basically just piped into to the widgets. We typically reserve as like the state for the data a property called data provider. So, you know, and a lot of the stuff you can implement your own way. So the data provider, so let's say I have a grid, I get the service back from the back end, I have new data for the grid, I actually pass it in as an option to that option accessor, and you know, say this is the data provider and this is the new data provider. But I have to do that every time the service comes back. So I can't just say, create a widget, and this observable is the data provider, and then in the service handler, just update that observable and expect everything to update. You actually have to programmatically like say, give it to this, or give it to this widget, give it to that widget. So, you know, it's close to that, but it's not as close as I want it to be. Anything else?